Okay, 5.1 rational numbers. A rational number is any number that can be written as a fraction. So we'll take a look down here what that is. The terminating decimal is a decimal that ends. A decimal that ends, so something like 0.123. And a repeating decimal is something obviously that repeats. So 0.3 repeating would be written like that, or 0.45 repeating would represent 45, 45, 45, and that's the pattern that repeats. Whereas 0.3 repeating was just 0.3333 on down the line. So let's take a look. We said rational numbers are any numbers that can be written as fractions. And it says here, show that the number is rational by writing it as a quotient of two integers. So quotient means dividing into integers. So a number over a number, which is our fraction. So if we can write it essentially as a fraction, we're good to go. 7 could be 7 over 1, rational number. Negative 10 over 1, rational number. 5 and 3/4, we want to turn into an improper fraction. So I multiply 4 times 5 and get 20, plus 3, I get 23 over 4. Keep it over the same denominator. For letter D, I'm going to tell you to ignore this negative and just solve like we did here. So 3 times 2 is 6, plus 1 is 7, keeping the denominator of 2, and then add on this negative. If you do it the other way, you're not going to get the right answer. If you do 2 times negative 3, you get negative 6. Negative 6 plus 1 is negative 5. So you're not going to get the right answer. So tag the negative on either at the very end or the very beginning, but don't count it in your problem. All right, you try. 22 over 1 shows that it's rational. Negative 15 over 1 shows that it's rational. This would be 21 over 2, showing that it's rational, and this would be negative 25 over 3, showing that it's rational. Okay, now in example 2, we're going to write these fractions as decimals. So fractions and decimals are really part of the same family. They're just different ways of writing the same thing. So to write 3/8 as a decimal, it's almost like this is like something you built in the sand, like a building you built in a tower you built in the sand. And someone comes over, the wind comes over, and it blows it down. Okay, so this 3 is going to go inside. This line comes down, and it makes this line, and the 8 is outside. Okay, so that might help you remember what goes on the inside. Numerator's on the inside. Now I have to divide, so I have my place values. I go ahead, and I know that we're all good with dividing. I bring my place 0 down. I'm going to get 7. 7 times 8 is 56. Subtract, I get 4, and I bring that 0 down. And 8 goes into 45 times. So 3/8 is actually the same as 0.375. We're going to work on memorizing a few common ones, such as this one later down the road. Letter B, we're going to divide. 5 goes on the inside, 11 on the outside. Put my decimal place in, bring it up. 11 goes into 50 4 times, 44. Subtract, I get 6, bring that down. 11 goes into 60 5 times. 11 times 5, 55. Subtract, I get 5, bring down that 0. 11 goes into 50 4 times. And we start to see a pattern here, and you guessed it, we're going to have a repeating decimal. So 5/11 is actually 0.45 repeating. Okay, let's take a look at the next page. Oops, I went to lesson 5.2. You want 5.1. There we go. I'm going to skim through these. I'm not going to solve all of them because you would do the same thing dividing. But I want to look here at letter C real fast. You have two options. You could either turn this into an improper fraction, so you'd get 29 over 20, and then divide that with the 29 on the inside, 20 out here, and go ahead. Or you can recognize that this whole number is really going to be what goes in front of the decimal point. And then you could just do your dividing with 9/20ths and see what you get there. And whatever answer you get is going to be the decimal part. So you have two options. Whatever is easier for you, especially if you have larger numbers. Maybe the second way might be preferred, but 29 over 20 isn't too bad either. All right, example 3. Now we're going to go the other way, writing terminating decimals as fractions. So first things first, if I have 0.12345, this is my tenths place, the 1. 2 is my hundredths, 3 is my thousandths, 4 is my 10,000ths, 5 is my 100,000ths, and it goes on and on and on forever. But that's what we're going to focus on. This 7 goes out to the tenths, so it's 7/10. My negative 3 comes down, and this 0.05 goes out to the hundredths, so it's 5/100. But we don't want to leave anything unsimplified, so really this is negative 3 and 1/20th. Letter C, I bring my negative 9 down, and 42 goes out to the hundredths, so it's 42 over 100. And then I can reduce and simplify, negative 9 and 21/50ths. Even if it doesn't say simplify, you should always do that. It just goes without saying. The answers here are going to be 1 and 7/10, 52 over 100, because it goes to the hundredths place, but then we can simplify and divide to write equivalent fractions, reducing it as far as it can go to 13/25. Letter C is negative 1 and 45/100, which is going to reduce to negative 1 and 9/20. Now let's take a look at example 4. This one's a little different. Write a repeating decimal as a fraction. Now here we can't see how many place values it goes out because it repeats. 0.939393 keeps going forever. So the first thing we do is we write let x equal 0.93 repeating. Now because it has 2 decimal places, we're going to multiply it by 100 on each side. 2 decimal places that repeat, 2 zeros in the 100. That might help you remember it. So I multiply both sides by 100, and I'm going to get 100x equals, now when I multiply by 100, I really move my decimal point 2 slots. So now I have 93.939393. So this part's still repeating. All right, I'm going to get rid of that so we don't clutter ourselves up. So this is what we have. We multiplied by 100. The third step says subtract x from 100x. So I'm going to subtract x, and x equals 0.93 repeating. So I'm going to subtract that. 100x minus x is 99x. Over here, this cancels, goes to 0. That cancel goes to 0, and so would all of this. The only thing that's left is 93. To solve this equation, divide by 99 to get x by itself, and x equals 93 over 199, which is actually 31/33. Now let's practice a few more. Now this is the long way of doing it. You'll see a pattern in a moment, but it doesn't want to go. Let's try again. There we go. Okay, so write 0.72 as a fraction. So what we want to do is we want to do x equals 0.72 repeating. Now we multiply both sides by 100, so we see that because there's 2 places that repeat. They're different digits. 100x equals 72.72 repeating. When we subtract, we get 99x equals 72. Divide by 99, divide by 99, x equals 72 over 99. And then whenever I simplify, I get 8/11. Letter B, x equals 0.34 repeating. Multiply both sides by 100, so I get 100x equals 34.34 repeating. I get 99x when I subtract, and my repeating parts cancel, and I'm only left with 34. So now I divide by 99, and I get x equals 34 over 99, which doesn't reduce. Now the pattern here that you may have picked up on is whatever our repeating decimal is goes over 99. 34, 99. So here it's going to be 14/99 without doing all that work. Here it's going to be 77/99, which is 7/9. And this you also could have said 0.7 repeating is the same thing, because it's only one value, it would just be 7 over 9, which we see equals. If I would give you one more, 0.123 repeating, that would be 123 over 999, because there's 3 values, and simplify if possible. All right, last problem, ordering these numbers. First, turn them all into decimals, because that way you don't have to get common denominators. If you would turn them all into fractions, you would. So I know that this is what they're equal to. Now put them in order from least to greatest. So you get negative 4.3 repeating, negative 3, negative 2.5, negative 1.25, negative 0.2, and then 4.31. And it helps to cancel them out as you go. All right, now the last step you want to do is put them in the way they actually showed up originally, and then you're done. Okay, so this would be negative 4.3 is negative 13/3, negative 3 is good, this is negative 5/2, negative 5/4, negative 0.2, and 4.31, and you are done.